Hello friends, once again few more limits for L'Hopital. Let's get it started. We have a limit x towards 0 of 1 plus x squared to the power of 1 divided by x. Well, it is kind of similar to the exponential function, but um, with e we have x running towards infinity. In this case we are running towards 0, so it's kind of yeah, the base is running towards 1 and the exponent is the power is running towards infinity, so 1 to the power of infinity could be unknown. So let's figure it out. We have a limit x towards 0 again, e to the power of ln of 1 plus x squared to the power of 1 divided by x. That would be a limit x towards 0, and once again this is e. And now we have ln of 1 plus x squared just divided by x. So this is the power, and we would like to figure out what's happening. ln at 1 is going to 0, and x is going to 0 as well. Once again, whose speed is greater, who is going to win? Let's do it on the next page. So we have a limit x towards 0, ln of 1 plus x squared divided by x. It's clear what to do here. So we have in both cases x running towards 0. We have in both cases tendency to 0 in the numerator and in the denominator as well. In the numerator, we're going to get, through the chain rule, 1 divided over 1 plus x squared times 2x. In the denominator, we have 1. So what's happening here if x is running towards 0? Are we in trouble somewhere? As you can see, 2x is becoming 0. 1 plus x squared is becoming 1. So the result in this case is 0, which means the speed at which ln of 1 plus x squared approaches 1, the ln value approaches 0, is greater than the speed at which x is approaching 0. So it's kind of steeper, faster, and so on. So we get the power equalizing 0. So it's e to the power of 0, which is 1. Limit number 1 for tonight is done. Let's see how many more I gonna make. What about limit x towards 0, x to the power of 1 divided over 1 minus x. Once again, we start doing the same. This is e to the power of ln x to the power of 1 divided by 1 minus x. So let's write it as limit x towards 1. We have e to the power of ln of x divided over 1 minus x. And once again, we are now approaching 1. The numerator is approaching 0. The denominator is approaching 0 as well, since 1 minus 1 is 0. So we would like to compute actually the limit x towards 0 of the power, which is ln of x. Was it x? It was, divided over 1 minus x. So 0 divided by 0, both differentiable. L'Hopital is calling limit x towards 0, 1 divided by x here, and minus 1 there. So basically a limit x towards 0 minus 1 divided by x. Well, this is not a nice limit, if you remember that, because it's not clear from which side are we coming. Is it clear maybe through the definition of the function? And the answer is it's not. Okay, so I do not know what's happening here. It's either plus or minus infinity, and limit, well, this is a huge difference between the outcomes, right? If it's a plus infinity, we're gonna get to e to the power of plus infinity, which is an infinite number, infinitely a positive large number. And if it's a minus, if it's a minus infinity, then this is 1 divided over e to the power of plus infinity, so it's 0. So in this case, we have no value given because I got no value here. All right. That's nice. I was going towards 1, not 0. Okay, guys, that's correct. This limit is 1. This limit is not given, but if I'm approaching 1, it's a total different outcome. Welcome in the world of mathematics. If x is running towards 1, which this is a limit which is very famous for not working if x is approaching 0, but now we are really working with a different one where x is approaching 1. Let me correct it. I'm not going to push artificially the watch time of the video. This is really happening live. So 1 here and 1 there. And 1 here, and now it's a different one. This is truly -1. And I'm coming back now. I have to erase it as well. So the total power is -1. So I got e to the power of -1, which is 1 divided by e. Okay. I have to do one more correctly. Then I can sleep well. So it's going to be a limit x towards 1 tangent. Oh my gosh. Pi divided by 4 x to the power of tangent. Pi divided by 4x again. Well, that's nice. Let's see what's happening. We got the limit x towards 1, once again e to the power of ln tangent pi divided by 4 x to the power of tangent pi divided by 4 times x. Again, we can kick it down. So this is a limit x towards 1 e to the power of ln. No. I keep e this way. This is ln of tangent pi divided by 4x divided by tangent pi divided by 4x. That's nice. It's going to be a nice limit which we have to compute. So what is the power here? We don't know. Let's ignore the mistake from the previous example. So let's not switch between 1 and 0. Let's keep x running towards 1. Are we in trouble actually? If x is 1, what is tangent of pi divided by 4? This is 1. So this is basically, do we have 1 to the power of 1? Is that all right? I mean, do I have to do this stuff? Let's see. Tangent of pi divided by 4. This is 45 degrees. So this is really truly 1. So I got 1 to the power of 1. I have 1 here. And I see no troubles here. Maybe there is a mistake in the book. But you know what? I came so far. Let's produce a derivative as well. And this is kind of, you see, that would be ln of x divided by x. Who is winning if x is approaching 1 and this is going to be 0? Right? So if x is approaching 1 in this case, I would have 0 and e to the power of 0 is 1. So there is no need for L'Hopital. Really, I just don't want to do this. It's going to be 1 divided by tangent if I derive it, right? And then times the derivative of tangent, and this is also the derivative of tangent. No need, truly. I don't know why it came in this book, but let's keep it this way. So this whole fraction is going to give us 0, and that's why it's e to the power of 0, which is 1. Do you see why it's 0? I mean, we have ln of x divided by x, and we are approaching 1. Okay, so tangent pi divided by 4, x is behaving like x, kind of, like an unknown value, right? And, well, in this case, it's surely 1. And 1 in the denominator, it means 0 divided by 1, because ln of 1 is 0. So 0 divided by 1 is 0, so we got e to the power of 0, which is 1. No L'Hopital here. 2 cases with L'Hopital. No need for L'Hopital here, it's also fine. Thank you for watching. See you in the next video. All the best. Bye-bye.